All right, hello and welcome to our dissemination seminar of another DIGIMAN project. Just a background, we did do a little bit of Google research. A lot of projects like this are named DIGIMAN, but still we wanted to use the name because it's a nice name. You already know today's schedule. It's going to be around 2 hours. With a little break in the middle, 10 minutes for testing the Zoom participants of the panel. And then after that, the participants here on location can have a little lunch snack and a tour of several TalTech laboratories, faculties. The background of the project, it is financed by Iceland, Liechtenstein, Norway grants. And there's 3 main partners, as you can see in the bottom. TalTech Virumaa College, Profmof, private company dealing with MOFs, metal organic frameworks, and NTNU, Norwegian University of Science and Technology. And the overarching goal of the project is research and education. A little bit more in depth is enhanced knowledge development. And in our case, our project was concentrating on Baltic and Norwegian cooperation and to be specific, cooperation in education. But for the practical side, we included Profmof as one of the companies from Norway. First of all, I'm Mihkel Kahju. I didn't introduce myself. I'm the project manager. And today we also have another speaker. He will introduce himself, and then a short panel afterwards with introductions. Numbers are usually boring. I hope this one maybe is not that boring, but maybe some numbers are exciting here. So the project started November 2021, and until today there's been 1.6 years, or 1 year and 7 months. Don't worry, those are not the only numbers, but it's just I think a fun way to see that's in total of 14,000 hours we had to get it all together. But of course, all the project participants had their main full job and additional projects around it. So it's not that we spent 14,000 hours on it. It's just the timescape. How the project was made, or what was the process in it? We started with firstly, after handing in the project application, we needed to fine-tune the actual plan for it. So the core team of Allan Niidu from TalTech Virumaa College, Andrei Lobov from NTNU, Karl-Peter Lillerud from Profmof, and I, as the, so to say, administrative side of the project, or project manager, its official title. We worked out all the details and then proposed the initial team members who would carry then the modules. In December, there was the full team meeting with the proposed team members, and we explained them the expectations and then made the initial agreements. Almost another half a month later, they presented their initial concepts for the modules, and from there on, in February, we went on for the detailed module plans. One of the parts was study and assignment plan, so we knew what the students in the module would be studying and which kind of assignments they would be carrying out. The keyword here was as practical as we can go with those assignments. We had 4 physical meetings, additional to Teams meetings. The first physical meeting was in Norway, where we presented the module work we done, and we further developed the modules between us. From April till June, we perfected the modules individually, and we started to plan for the summer school. Initially, in the project plan, it was planned an implementation for the project or the course in one of the schools in NTNU or TalTech. However, it was sort of maybe my mistake of the site. I didn't see all the red tapes that there was and the time scope there was to actually implement the full course in one of the one of the schools. So instead we made a summer school, which was a kind of shorter version of the course where we can test the modules one by one. Right, in June, after this individual model tuning, let's say it so, we had our second physical meeting in Estonia where we presented the modules. We developed them again further, and of course we needed to start to condensate them a little bit for the summer school, because we just had 5 days to have these 1 semester full of modules presented to the guinea pigs, to our doctorates and master students who took part in the summer school. And in August we had the summer school with 19 participants. There was 5 universities backgrounds there, one way or another, and people flew there from 7 cities across Europe. So it was truly international summer school. Actually, would have counted the nations as well. There was even more nations, I think, than cities in the end. Then from September to December, we of course improved the modules again from the feedback we got from the summer school, and I will tell about the feedback in the background as well, in the conclusions part. And the other thing we did, we randomly assigned the modules to each other in our team to cross-check them and get even more critical feedback and even more constructive kind of improvements. Again, meeting in Norway, our third meeting, physical meeting, where we presented the modules to the summer school students now almost half a year later. And those were the students who were from the Nordic countries originally, and they gave us then the feedback and how the summer school resonated for them, and what they saw were the most interesting points out of it. And of course, we improved the modules as we could. Another timescape of a few months went over, and in that time we started already consolidating the 9 modules into one course guide, and of course there were still some final improvements to do on all of those modules. And almost a month ago we had our final physical meeting in Estonia, and we presented now these modules to the TalTech students. Unfortunately, the turnout wasn't as great as in Norway. However, we got some valuable feedback from there as well. And here we are, almost in the end of the project. We have the modules ready, the data ready, and it's ready for sharing. Only in project timescape, it's the paperwork in the end to do. And to continue in numbers, it was 14,000 hours ago. In total, what we share also to all the you who registered your email, you can access these files, the whole course, and it is around 11,000 files, 2,000 folders, rounded up, and 4 gigabytes of different kind of knowledge and data. And as I said, there's 9 modules and 1 course guide that kind of summarizes those. Yes, and again, more numbers. There's 7,000 revisions we did for those course guides and module guides. They're totally 88 pages in 500 paragraphs, more or less, and lines and words and characters. So in total, those are not the facts that is important how many words we typed, but it just shows that that there was a lot of iterations and a lot of editing and a lot of criticism and a lot of improving in those times, and rounds of feedback and such. And final fact, email. I found this number funny because incoming emails for me, there was almost 1,000, but outgoing is less. For a second I thought, did I do less work than others? But then I realized every time I sent out an email as a project manager, I sent it to 3 to 9 people. So more emails came back than I sent, almost always. Right, but on to the content actually. What is inside of those modules, behind of those numbers. And very soon Andrei will join me, but first I'll just go with the form side or the structure side of things. Currently in TalTech and also in NTNU and many universities, I'm sure, the courses are actually explained really briefly. So it's, in my words, it's like it's more meant for the IT guys, or made by IT guys for IT guys, and not really for people to read. So example, as I showed here, it is 2 languages, so it seems like there's a lot of explanation, but there's really, really brief content. And even if you go deeper into the documents, you actually don't get much more explanations of how you do it, the time scope exactly week by week or anything like this. You just get a brief overview, so to say. So the point of this is a similar situation, for example, in NTNU, but in other universities as well. The goal for the structure side or the forum side is to actually give the students the idea of what they're going to learn, how they're going to learn it, what is the methods they're going to learn it with, how is the walking through experience through the course. So on that side, the new course looks like this. I know you don't see the detail on here, but that's right now not the point. What is just illustrated here is, if I show with the mouse, the course dashboard is the part actually is existing right now in most of the universities as well. But there is not much walking through the course for the students, for the people that are experiencing the course. Or in this case, as our 9 modules are also used in the future, hopefully, most probably, to train also people from enterprises, from the companies. If there's one or another module that seems interesting and necessary for employee or a company, or the management sees somebody needs this knowledge, then they can pick one module and vote for it in the end as well. We have a little vote here. And these modules can be taught separately, and the module guides give a really good idea how it is taught and what's the content actually inside those models, and what's the necessity and what's the connection to real life, the practical connection. So the introduction part gives like an overview of the entire module. In this case, the entire course. This is a course guide here right now, so it's sort of an executive summary of the whole course of the 9 modules. The type of course and the role of the student and the lecturer gives an idea. Is it more theoretical? Is it more practical? Is it introductory? Does it go really in depth in some or other detail? It just gives the depth and the scope of the course. And the roles of the student and the lecturer is one of the parts that really gives it the real life taste, so to say. So for one example, the role of the student is maybe a consultancy worker, or a consultancy company even, or a team of students represent a consultancy company, and then the lecturer takes the role of another company or a person who wants to start a company maybe. So the students will get a task to solve a practical problem for this company or for this person. So they get a feel in this example. What is actually the reason why I'm learning this module, this theory, this also practical things behind it? Where do I use those things in real life? What is the application? Because more often today in education we just get the knowledge, but often the questions where I'm going to use it in real life is left unanswered or not answered clearly enough. So this gives kind of the structure to explain it. How is the dots connected in real life? The next chapter, course setup. The course setup is walking the student through in the meaning of time. Either it's the whole semester, 17, 18, 16 to 18 weeks, depends on which school internationally. And depending on the module, it's either days or a few weeks which the module goes through. And it can go hour by hour if there is a need for a module inside the module. There's also resources explained, the skills and accesses needed. It can be tools, it can be computer programs, software, hardware. It can be physical tools as well for some modules, or also, did I mention knowledge, skills, knowledge? Yeah, it's more or less the same area. So everything that the student needs to get the maximum out of the course or the module. And finally, of course, the assessment and the grades. So how is the work assessed? What is the deliverables? The keyword here maybe is deliverables, because there needs to be something delivered. There needs to be something that they make, something that they form. So that's the side of the deliverables. And it can be done in some cases piece by piece, that they do some little pieces, and in the end it gets the final assessment. Either the pieces are added up to 100%, or it's another way to grade them. And of course, the sources and study materials is a natural part of any kind of document. And in this instance, for the course guide, we did not include everything that was in the module guides, but otherwise it would be 10 more pages just of quotes and sources, so to say. Right, but the content. We have 9 modules, as I mentioned a couple of times, and those modules are in front of you now. It starts with just an overview of digital manufacturing. What is it about? What's the history? How it has evolved? Where are we now? Where are we going? The business and administration module kind of explains the importance of the digital manufacturing for a business owner, for a management. ICT, of course, it goes naturally with digitalization, with digital manufacturing, but this module just looks at it a little bit in depth, maybe septically or segmented, but it does focus a little bit. Although the ICT is included almost in every module, some way or other. The digital energy production discovers the ways that energy is produced, how the digitalization is applied there, and what is the future of it, and some practical exercises, of course, in every one of the modules there as well. The material science, the module 5, concentrates more on the visual side of materials, maybe, and what do you say, the context of it as well. But acoustic emissions brings another interesting kind of angle and the interesting thing or aspect to measure. So to give an example how one aspect, meaning acoustic emission, can be used in different ways of analyzing materials, their wear, their function, etc. Digital chemistry is perhaps one of the heaviest modules in the list, and that was with the original goal, because Virumaa College is strong in chemistry as well. And it goes to the molecular level of MOFs, in the example of MOFs. And you can see how molecules come together in the computer, in the virtual world. And the use for that is to simulate what happens with some materials and how they form virtually before you go in the lab and actually have to either waste materials or time. Second to last, engineering design. It's actually complex engineering design, and as well it brings together the computer world to enhance the simulation and testing of different engineering designs, and to see beforehand how these new products or new solutions are working in the real world, or how would they be working or not working. And finally, last but not least, robotics, of course, a big part of digital manufacturing, shows the virtual side of robotics and the physical side of robotics, how those domains contribute to this entire scape of digital manufacturing. And that's the whole DIGIMAN. That's what the course is made of. The document just summarizes them, but the long name, the multidisciplinary knowledge integration for digital manufacturing, in short, DIGIMAN, that's the 9 modules. And Andrei will explain them piece by piece. Yes.
Yes, thank you, Michael. Yes, good morning, everyone. It's my honor to be in front of you, presenting the work of the team from Estonia, Norway, from ProfMOF, NTNU, and Taltech. As was said by Michael, we are dealing with multidisciplinary knowledge integration, and here we have those 9 disciplines. So maybe first look can be like how this can be integrated, why those disciplines, what other things we can include. And the word digitalization here is one of the, well, central words. So ICT technologies, information communication technologies helping us to integrate. My goal here is to go briefly through the modules, obviously not with not intention to teach them now, it's impossible, but to give some insights, some examples. Yes, starting with the whole idea, motivation, we can have products, they can be coming from different domains, and they can be represented in some digital models. Here is a 3D model showing some part that has dimensions, some complex shape, and it's represented in computer-aided design tool, where traditionally, engineer can manipulate those parameters, length, width, height, curves to get the right shape. Then this can go on to modeling and simulation of production system that actually may be doing this, some processing of these parts of some operations in some milling machine tended by a robot. So again, what it intends to show that such models, systems can be represented digitally. And one can then check how the workflow goes. And comes sooner or later a question of integration, how to put all this together. And very general, simple answer could be seen as, okay, let's try to see those models, and I would like to here highlight a triangle of product, process, and equipment or resources models. So on the product side, we have everything represented of those length, width, heights, and some reasoning why those are there with this product. Then resources, manufacturing resources, equipment that make required operation to mill, drill the holes in the right places of that part. Or again, industry can be different if it's a process industry, like getting a possibility, a reactor that can enable certain function. So products, those models can express needs, and those needs are represented in terms of processes required. So like I was mentioning, drilling, milling, in the process industry, it's probably some reactions, as I said, adding components, giving time, so chemical reaction, so depending on the domain. Then resources can represent their capabilities in terms of those processes that they can allow. So like a chemistry labs to support certain reaction synthesis. This type of production line, some mechanical operations, operations on materials. Okay, and we can push, here is this question, can we make a match between product needs and resources capabilities? And when can we make this match? Can we push it to some extremes, making at the system runtime, at the production system runtime? For example, we can get a flow of orders from the customers, clients, operators for that system, and there can be some intelligence deciding, okay, yes, can we do it now? This decision making requires support of information systems. That's why we have so many disciplines, as we try to look through those disciplines, what digital automated analysis tool they can give us to be integrated into this picture of automated decision making and how far we can go. There are traditional systems. You may not know these abbreviations, but there are established information systems around, like product lifecycle management, manufacturing execution system, those MES, PLM, as you see. Then we can have those enterprise resource planning system, so which stands usually more close to organization decision making, so like in interrelations with the clients, with the suppliers, so carrying out these important business functions. And then our enterprises exist in some context of network supply chains, where we can have several enterprises adding their know-how to a product at each state, forming some complex, well, as was mentioned by Michael, engineering product, so like ship, airplane, like some outstanding examples, where or automotive industry, where those supply chains can be quite long, but, well, not necessarily, like even to some simpler cases, there might be already quite complex chains formed. And question is how all these levels and of decision making, where to purchase, what to purchase in terms of delivering a product to further in the next organization in the chain, how this affects on triangle in the center, process, product, resources. Is there any effect? Well, that's interesting questions and valuable, because this may allow constructing also resilient supply chains, making very rapid, fast response to a change, and, well, building more healthier business environment. So these are the modules, and going a bit more to give you what you are expected to see. Behind those study guides, well, Michael has shown you a course study guide, but each module has own study guide. So again, explaining different roles of a teacher, student, organization of the module. And here is example of a lecture slide with the content for digital manufacturing. So what it is, what is MDO, multidisciplinary design optimization, integrating all these different knowledges for decision making. So here you have already some item 7 selected languages, well, Python, general purpose language, some knowledge fusion, some specific language. So all this explained. And in the corresponding slides behind this, yes, in addition comes, I should mention, source code in those knowledge fusion and Python, so exercises prepared so that if you are going to teach this course, you have already some examples that you can integrate into your course. So business and administration, topics highlighted, business value chains, what I have been just speaking a few moments ago, digital enterprise history, tools for digital enterprises, and then collaboration and knowledge flow within, and then again coming to selected practice sessions, languages and tools there. Here is just some also slide exercise, simulation exercise example. What it can literally mean, you can see here central database where you try to integrate different enterprise functions that go towards customer, and on the left side, or then to suppliers on the right side, so to enable again flow in the supply chain. And corresponding functions, sales, delivery, service, human resources, financial applications. those are supportive functions. Some of those are supportive functions of the enterprise, but still may affect how we run the business and administrate business. Then ICT, I would see as a backbone to support information flows and integration of those different selected disciplines. So here is just example of what you may expect to see in one of the lectures there. So you see that we try to address some fundamental questions like why programming, what languages to choose, why to choose those languages, what are different formats for data representation, like in item 2, why those formats, so how to organize these information flows. And again, to illustrate with the example, what programming language to choose, well, we can have two poles. On the left-hand side, you see close to low-level programming languages, close to the machine code, like assembler code that we have started in 1960s. Use then more developed some examples of procedural programming language like C. Then object-oriented programming languages starts to emerge around 70s and move us towards higher level, close to problem domain languages. So at some point, like around Java, Python, JavaScript on this scale, we go away from programming language to representation language, or to so-called, as what highlighted there, problem domain languages, like getting markup languages. So I can maybe speculate here, we stop programming, but we start to configure our system, and getting, again, whole idea is to get closer to the human, to the stakeholders, to, in our case, maybe to engineer, to let him, her express things in more usual problem domain specific expert language. So, by the way, these slides also has in the corner main developers. So this module was mainly driven by Liang Zhang from NTNU side. Okay, then digital energy production driven by Victoria Mironova from Tech Viruma College. So again, how we, example of one of the lectures, how we produce the energy. So here is, like if you see item 2, digitalization and buildings, transportation, industry, digital twins, which I just want to again bring one example. Digital twins, one important topic where we get a digital replica of actual physical plants, objects. They exist in many industries nowadays, in many domains, starts to be developed. And why these help improving decision making? They feed on the real data. They open up possibility for predicting what will be happening with, well, our controlled object. And as you may feel and guess, there is again a lot of data integration, a lot of algorithms, or some, well, algorithms have to be identified that can serve best, in each particular case, prediction function. So then digital material science example. Here we have here and in other modules we focus on different methods, tools. So here is for digital processing. Under item 2 you can see a set of methods, same as whole section finite element, modeling and analysis. Item 3, strength of materials. So all with the idea to check of what our products are being made and how these, what they are made of, affects the performance. So like one of the simple highlights of finite element method. So we can have, as you may see on the right, a heat map of some structure, cylinder or pipe, and we can apply finite element method for different applications. Here is just illustrated with heat transfer, so where we divide our object we analyze into small fractions and then apply, analyze how the heat is propagating. So here is a snapshot set of MATLAB code, so another digital tool, rather generally known, but still there are different tools, there are different languages, and still question what stands for integration is how to bring this digital zoo together of different tools and different formats, languages. So this module also, to highlight, developed by Veronika Shirokova at Taltech site, main driver here. Then to go further and to illustrate that we can have different ways to analyze our materials, and again how they perform this selected method of based on acoustic emission is coming in a dedicated module, so covering data processing, what the introduction, of course, of acoustic emission, and with some exercises on that, so done in Python. So here is, we can see there are different, when we try to analyze on our systems on different scales, we can have, passive, ways, active, destructive ways, where we can, on the right-hand side on the horizontal axis, destroy it as a result, our product or sample that we analyze. And more to the beginning, we have a passive, so non-invasive, non-destructive, so like simply, for example, observing the sound and making analysis and conclusions based on this. So if the previous, like FEM, we can see this method as example of method we can apply at design phase before we even start fabrication and use of a product. Here, with acoustic emission, we can have already system installed in use and with acoustic sensors analyzing the signals and deciding if and how system behaves. So this module driven by Håkon Tvedt from NTNU side. Digital chemistry, yes, I also highlight the heaviest module, content-wise, so driven by Carl-Petter Lererud from ProfMOF and Alan Nidu from Taltech. For me, it was very interesting to see how far we can go with digital representation and modeling. So basic theme here, if we are not, there are not enough, with the current materials, not sufficient to solve problems. What about synthesizing new ones? And digitalization can also go there in 3D, modeling the crystals. In the exercise, as was mentioned, we had like some iterations, checkings. It was interesting to learn how to throw atoms to this 3D canvas. I have been more experienced of throwing, like cylinders, cubes, then making shapes. But here you draw atoms and then making bones, forming molecules, structures and then trying to analyze. So students will get exercise, can get exercise about it, and all of analyzing the properties of generated materials. Yes, robotics. Also, well, robot is a tool that helps automating, supporting manufacturing. It as was shown in the beginning, like tending some machine, but it can also do many other operations. Here is a short summary of also one of the lectures to give you some insight what you can expect. So, like to learn what is for students to learn what are the industrial robots, but also what digitalization tools we can use to analyze their behavior, performance. And yeah, just here is examples where you can add, in this case, anti-effector highlighted. You can specify properties, orientation, position of that effector, going really defining the structure of the manipulator and then animating its operations. So last but not least, I should mention digital engineering design. I put it in the last on the list of the modules, coming as a one summing conclusion, building complex products. So here is illustration of a chair, and we try to use in the code, in the exercises for students, some general well understood objects like a chair, and try to reveal what can be complex and what can be integration challenges with those structures as well. So here you have example of online system of online chair designer, where user can get parameters and get chair generated. So there is some formats, codes that get to the product outlook. But it's not the only thing that has to be done on the product. We should consider many different things. Among them, like here highlighted in the lower left corner, is this design viable? Is this optimal enough? So what means to be optimal enough? Well, price, safety, longevity. So this cartoon in French intends to show that, okay, yeah, we have super light materials here, super design. But yeah, okay, very, very nice, and then yeah, ends up still not satisfying really some of the parameters that should be there in the product. Yes, again, to highlight, we have module guides for each of the modules, structures, defined exercises, defined in different digital tools. Like I try to show you some of those examples, and how this can be put together. So just an example here, we can have energy plan is the tool that we can use for analyzing energy consumption. ERP here shown, enterprise resource planning, as a central system. It can integrate with one of the tools. Siemens NX is just one of the possible tools for representation of a product. We can make analysis of if this product meets customer requirements based on the information received from ERP. Then we can have some FEM, what was highlighted here, analysis, dedicated Python module, MATLAB module, any other language model. Then this information can be routed in the startup topology through ERP or directly linked between Siemens NX and that's dedicated module. Material Studio comes, chemistry, if we generate new models, and then we can say some properties of materials based on output of material studio integrated into FEM analysis, or again through ERP. And if and as there are some robotic operations, we can continue adding the tools to have a holistic enterprise, a digital enterprise view. So another naive maybe representation what we are trying to do. We are trying to compose digital tool chains for solving multidisciplinary challenges. Yes, there are many disciplines, not only solving one particular thing at the time, but there are those challenges can be linked to the selected subset of digital tools that can be put together when and as needed dynamically. So, okay, well, where we are going, we're still going, but I'd like to illustrate with this meme. So, this is a movie, I, Robot from 2004. Not sure how the modern audience is remembering, familiar with this, but this is Robert, the actor playing interrogator. He interrogates a robot, asking, can a robot write a song, create art, write a code? The answer at the time was, can you? So returning the question, but now the joke continues. Now we can, and I'm referring, at least when I saw it, to my ChatGPT example. So when it's already, you were having a doubt if certain things are possible, and then suddenly it starts to feel reachable, possible. And what is our part, what we are trying to push for, integrate those multidisciplinary tool chains, so running those digital enterprises. So we may come there at some point. So to conclude, how you can get those materials. So on the table you have those who are physically with us, guides there. So we are intending to put also information and access to official project website. We created a group of so-called DIGIMAN keepers that provide access, and we give access to everyone who requests, so no any barriers there, but we would like just to have a channel to understand the need and the interest. And path is this dedicated email, digimal@mtp.nu to request the materials. Thank you very much for your attention.
Right, it's now time for a break. We will get the panelists on that are coming through Zoom throughout the break. And those who are here can still either grab the copy. If you haven't signed your name, you can sign your name and everything to there, please. And there's 2 questions that you can access on that address. I will also put it up, where you can have a QR code to answer those questions, because we cannot really give on these practical sides of these models right now. So if you just read the names of the models online and you got some idea what's inside of those models, then first question, which of those modules seems most necessary or applicable to you? And the second question, is there something missing? Would you like to see some other topic that isn't touched here in the modules in depth? We know one, for example. We got feedback that we could do security, cybersecurity, a bit more in depth as a separate module. There could be another one. So those two questions are out there for the break for those online and here, and we'll be back at 11 o'clock exactly, starting the panel. So questions, answers, and then I think one really crucial question and answer is the practical side of how this can be used by enterprises and other people who are interested. So see you at 11. All right, welcome back. I hope you did answer the questions that were on this slide by QR or by the address. And now it's time for the panel. We have 3 people here, which is me, Mihkel Kahju, of course, and Allan Niidu, who is one of the co-authors of the chemistry module, and Andrei Lobov, who was responsible for the content side of things. If I was on the structure and administrative responsibility, then Andrei has the content responsibility on project management. And online we have Håkon Tvedt, if I'm not mistaken, and Liang Zhang. I don't know if Björn has joined us as well, but we'll see. And Håkon was then the author of acoustic emissions module, and Liang of ICT module, and Björn then complex engineering design. Right, I'll take a seat. So start with the questions. I'm moderating myself because it's a busy time in the university, and we couldn't find anybody who would allocate 1 hour for this short trip to here and to interview us. So first questions to all of us, and then the people online as well, or the participants, our participants, then team participants. What was the motivation of joining the project or doing the project for you? Let's start with Allan, maybe.
Yeah, hello. For me, the motivation was kind of chance to check out digital tools for chemistry. So one thing is that if you think about, let's say, industry, most likely you're going to think about automation. So that's the first thing you think about. So the next thing is that if you have thousands of sensors, kind of getting information from a process, then you could use also that data to kind of optimize via, let's say, machine learning. And the other thing is that in order to get there, you have to have materials as a catalyst, you have to have chemical processes, you need some products. The reason that we have this type of stuff here is everything produced by chemistry. So, and then you start with design principles, from the first principles, and you want to design new materials, and for the future you would like to have materials that can be recycled easily. So right now we don't do that, but in the future we should have that. So that was the motivation.
So yeah, to summarize, to see how your area is translated into a digital world, more or less.
Yeah, exactly. So it's kind of what has happened recently, let's say, from an analytical perspective, image analysis, that's a trick that used to be that you had to have expert with training like at least 2 to 5 years to understand all the nuances, but right now and machine learning has done for you image analysis so that in 5 seconds you get all the data which you had to do hand by hand from the image previously. So there has been immense kind of use, kind of explosion, I'd say, of digital kind of information and information reprocessing. So, and that has helped a lot. And in the future, we hope that, let's say, we do the materials, we do the analysis, and take the data from there directly, and go to the next step of simulation. So you go to the factory, you go to the chemical processes, and then maybe you have, let's say, shorter cycle from the idea to the actual manufacturing. It's also a problem right now. I have idea in the lab, like in 10 years, it has maybe pilot, and then in 5 years, it's going to have a real factory, so 15 years minimum. It might take even 20 years, so let's say permitting is also a problem. So, well, kind of, and in principle, you could do that like in 5 to 10 years already. Let's say you would have new materials, new processes in use much sooner. And then maybe you can phase out the old stuff that's kind of more harmful to environment and start producing stuff more easily that's kind of more suitable to us in the future.
So, yeah, so to get to the result faster. How about you, Andrei? You're one of the main guys, meaning that you are responsible of the content. The vision of the content came originally from you. So,
well, thank you. Well, still it's team efforts. And well, speaking about motivation and looking to the world we are living in, well, where I'm living, like speaking about personal motivation, We have certain complexity around, and going to manufacturing products getting more complex, advanced manufacturing systems to support this complexity also develop with the time. And in recent decades, it's still not too old, we're still young, but still we have witnessed this huge transition thanks to the internet, where suddenly we can connect everything and communicate easily. And in that domain came development of relevant information representation and processing standards which have huge impact on all our activities, including that science and industrial development. So here is this question of how to integrate everything together. And as I was trying to show today with the meme, suddenly certain things seem to be at our grasp, and my motivation is that we are in rather safe environment to try out some crazy things, like developing a course that I hope can open this discussion how far we can go and eventually integrate our digital enterprises that, as Alan was telling, it may take some years before things actually start, but then maybe we can significantly reduce time there.
Right. So who's there online? Håkon, what is your motivation, or what is your motivation to join this project?
Well, I was approached by Andre, and just can't say no to Andre. So. But yeah, it was fun, and it's interesting to just see how you can fit your own stuff in with the whole thing. Like we really are on kind of like a precipice of something. So I think it's very worthwhile.
And how about Liang? I think the first initial answer is the same. I just can't say no to Andre. But Liang, what was your motivation to join the project?
I think it is. I think digitalization is a trend, and in many fields, for example, engineering, design, management, chemistry, energy, and etc. As my research is about the digitalization of engineering design, I think it is beneficial to learn the trends and the cases in other domains. And I think by this, to know how people in other domains use the digital tools, and to know the similarity, including the common issues and the difference, I think this is beneficial to my research. I think that is the motivation.
All right. I don't know if we have a third person there now joined us with them or not. Is it not or not? Right, okay. If Björn is there, he can answer as well, but I'm not sure if he's there. I think, yeah, there we go.
I think my motivation was sort of the automation part. I'm usually deeply in the numerical part of design checks and dynamics, but quite often it's difficult to achieve a timely result that's automatically tied to the geometry and changing loads and things like that. So the automation part was kind of my motivation, tying it to what is often more the design concepts and things. Yeah.
All right, so everybody got something out of the module as well. It went after some knowledge, as I can see. Well, yeah, I guess I'm the last one to answer. My motivation then was that I was the project manager. I got paid for it. No, no. I guess my motivation was actually as I became or was responsible for the structure of the course. My motivation was actually to create the course or an example of a course that is more, that is better or in a better way acceptable for a student, whichever kind of student he or she is. Because most of the team were scientists, and I am a guy who studied business administration and sales management. So all the topics for me were really strange, and my goal was always pushing people to, okay, I'm a layman. I don't understand anything about chemistry or programming or nothing. You have to make this course such way that a business person can understand it, so that he can see the value there, and that he or she can know how or why I should use those modules to either train my people or send my people to learn something, because all of those modules are teachable for gaining some knowledge in the enterprises as well, whichever part is needed. So that was my side of things, I guess. I think 2 questions as one is the next one. Did the project add something to your work or your studies or research? And if there was another module that did that, not your own part, which one was it? Like, did one of the other modules add something to your research, and which one was it?
Yeah, let me start again. So, well, yeah, I like to talk. Sorry about that. I'd say that about chemistry, so I was involved in digital chemistry module, and yeah, it taught me a lot, because of course I have used the main program that we are introducing there is Material Studio. But let's say how you integrate that into your everyday teaching, that's kind of it made it really easier than I would have imagined. And let's say also what gave a push for my people to try to learn it in more depth. So in principle, all my students now have to learn how to simulate the materials, how to analyze them, and how to get most useful information out of, let's say, digital analysis of molecules. So, yeah, that was really, yeah, I think it's really good that we got it.
But
yeah, I'm going to get to that also. So, what I would say that from the other modules, I'd say the general module is something that kind of, because yeah, I've been working in industry, but well, this digital manufacturing philosophy hasn't been there for me. I'm pretty much been process chemist, organic chemist, and that kind of person. So, well, there is automation to a certain degree. Yeah, there is, but using, for example, let's say, data analysis, so that you have big data and you try to find the patterns and try to optimize the process. That's not there yet. So that was really kind of fun part. So, and from a personal learning, I'd say that let's say it was acoustics, how you can use actually sound waves to check the materials for the, let's say, physical stresses, but also for physical properties, and most likely, to the degree you could kind of argue, you can probe also maybe chemical properties, but sometimes these are tied together, not always, but sometimes they are. These parts were kind of, and all in all, of course, I have more or less checked out most of it, and kind of it was in general kind of something that you can educate yourself on quite easily. So you just read the basic stuff there, you get some ideas, and since truly our part was most likely the most difficult part to learn for the students, so I'd say that everything else is really giving you the overall knowledge about digitalization in industry and per se, and that's something that, let's say, every engineer, or let's say from my perspective, every chemist that wants to work with industry, they should understand it to a degree. Yeah.
all right.
Yeah.
So,
If
do you still remember the question?
you can repeat it, right?
Yeah. Did the project give something to your discipline? And if there was another module that gave it to you, then which one was it?
Yeah,
More
so
interesting.
I have 2 words here to answer this: overwhelming and the hope. So it was overwhelming. Well, if speaking about from my disciplines, you get sometimes overwhelmed or paralyzed even to some degree, like trying to comprehend how many possibilities there are for integrating all those different tools, solutions, but there is a hope, there are the ways, and thanks to this project, developing this course, I started to see better the way, the path, and yes, the modules examples, well, to mention chemistry, surely, due to, well, it's out of my scope, was entirely, but then it was very interesting to really drag and drop those atoms, as I was telling, to 3D canvas, and, well, through this environment perceive that it's possible to analyze and potentially integrate to other tool chains for better decision making. So it's a question, I hope, for affordability of those methods, so meaning that it becomes packaged, wrapped in such a form that you can get these digital tools and with corresponding modeling and analysis capabilities rather in a simple and fast way when and as needed. So chemistry, then also to mention digital energy. So as there are also tools, models that are beneficial and are input to manufacturing systems, so to power production processes. So that was most well things what I can highlight at the moment. Yeah.
Very good. Yeah, I think those two are the top, sort of. But we'll hear from also. Let's do the same order then. Håkon, I guess. What is the most contributing model for you, and what did you get out of the project besides that?
Yes. Well, there was a lot of impressive simulation and modeling that I learned about from the other modules, which did indeed inspire me to think more about simulations in my own work, since you're working mostly experimental and theoretical. But you know, especially when we saw I don't remember what the molecules were called in the chemical module, but
MOFs.
You could literally see. Yes, thank you. You could literally you could show just the thermal energy of the atoms in the molecule, and that was blew my mind, kind of. And I also now am inspired to try and look at acoustic emission simulations at the very, very basic fundamental level to see what we can do.
All right. Yeah, as I said, the chemistry is like right now on the top, I guess. This is one of the most interesting modules. Right. Liang, how about you? Which other module seemed most interesting to you, or which gave the most to you besides your own work there with your module?
Okay. I think besides the detailed information like semantic data, different tools, and I'm glad to know that the digital trend has become a consensus in many other industries, which provides us a lot of opportunity. I participate in the ICT part, and besides this, I think there are many interesting modules that are new to me. For example, chemistry, acoustic emission, and etc. And I think among them, the automated engineering design module is directly relevant to me. I see one of the ways how the engineers automate their design processes. I think that is to write some codes for a specific task. And also, I see the demand to connect this calculation module to other tools. I believe this is a common issue in many other domains that the digital transformation is happening. I think if this can be solved, people can get a lot of benefits. That is what I learned.
Yeah, all right. So one point for the, it's like Eurovision, 1 point for the complex engineering design, as I read out. Right, how about Björn, the author of the complex engineering design module?
So for me, I think it was probably Andre's stuff, which is the natural point for me to tie into to start doing design checks and engineering design, and also Carlos' module more on the geometry and robotics stuff. It was really interesting. The chemistry and molecular level is very interesting, but doesn't tie into my work that easily in a way.
All right. Yeah, it's a bit more different direction of detail, so I won't deduct the point from you for that, from chemistry. Right. Yeah, I guess I would say also the acoustic emission first and then chemistry second, which was the most interesting. But in a way, nothing dies together with my work. I mean, or everything does, business administration or sales and marketing or whichever way. But what excited me the most was that if you go through the models, you can actually, being not a scientist, like I said, not familiar with any of those disciplines, what excited me the most was I could see the application of it. That actually going through this model, at least during summer course as well, and these exercises, you can actually see what you can do, what you can achieve with those tools that are presented, with the knowledge that is gained, and how you can either plan things, simulate things, solve things. That's the most interesting thing, I guess, for me. Right, just checking where we are with the time. We don't have to fill the time probably, but there's one really important question for some of the people joining us today and then seeing this recording afterwards. I hope I sort of baited a lot of enterprises to join our seminar as well. and the side is the practical side. How do you see these course modules or an example of one of those can benefit the companies, or how can enterprises use those modules and this knowledge right away? What's their use? What's their practical use in that?
Oh, yeah.
Thank
you for the words. So let's see, if we take the chemistry, then the chemistry is really kind of into the first principles, and that's, let's say, for the ordinary simple company where you don't do material science, it's really hard to get it from there. But if you take, let's say, the software side, you check about, let's say, image processing, then it can apply to pretty much many industries. Let's say if you want to check the quality of a material, then pretty much if you, let's say, the data is there and computers can take the data out of it and say that, let's say, your metal sheet, for example, you take the picture, see, okay, the surface, you see, let's say, some crystal structure that shouldn't be there. Let's say it's not processed as it was supposed to, and then you can decide, I don't want this material. Of course, you would like to have this beforehand, before you buy that, but even then you get an argument that you can ship it back or use it for another purpose, for example. But overall, if I think about it, then let's say acoustic emissions, maybe Björn's module, these are pretty much directly applicable. So you take the data there, how you simulate some stuff. Most likely, as your engineering company, you have the same software, similar software available to you. And you take the idea from there if you haven't had it before. You have this maybe code you can directly implement in your work. So in that sense, I think that most of the course is directly applicable to a company that is working in the relevant field. So it's easy as that. So if you have the code there available from the exercises, for example, and maybe we could even think, let's say, in the future, I most certainly will add some exercises to the existing ones, because over the years you want to develop it while you teach your students and take them from there. I hope the other guys will do the same. So you might have more examples, more code available, and that can be easily applied. So because you learn it and you use it.
Yeah.
Yes, and the engineers can use it every day.
Yeah, I guess that summarizes. We don't have to ask from everybody, I guess.
Sorry about that.
I can continue this thought and totally agree that some parts can be directly applied. We have some first companies examples where you can where the customer can send in parameters of desired product, and like in a few moments on web interface, web page, get a product outlook like as a 3D model. So basically, I see that in exercises we have a skeleton example that can be, if you wish, developed into online or integrated with your online shop. If you are manufacturing some metal structures, or
or wood, or a chair.
Chairs, yeah, furniture factory, yes, for example. But well, they can be like thought expiring, I believe, examples that rather simply can be integrated to your work. Yes, and overall, if we have some visionary, it's also important, I believe, for us and including companies in our society to maintain this spirit, I would say, of digital transformation. So seeing that the hope is there and be updated with technology. So there is also on the practical side, yes, some examples, some cases can be more easily integrated, but then as you get more developed, mature with your digital tools and their use, there is a possibility to go step by step, like getting your tool chain more developed with the time. So
Okay, yeah, module by module.
yeah, module
Step
by
by
module, yeah.
So yeah, what I take out of it then, what I can actually see out of it, I guess, is there's sort of two ways companies can use them. If they have somebody already who knows some of those programs that we exemplify in those modules, and knows a little bit of coding, a little bit of code, they can already download those exercises, go through them by themselves maybe even, and get some inspiration from there. And then there's the other segment where perhaps they don't have any programming skills yet, so they can either send the person to this module course if or when one of the universities give these courses out, because there's a lot of financing from Töötukassa, from different kind of parts, which probably will bring those courses alive, so people can actually start going to the courses, get the practical exercise, and use this code and those programs and this example from those modules. Depend on which modules seem most relevant to which company, I guess. So the practical side is there. I don't know if there's anything to add from the Zoom people, from the guys from Zoom, on the thoughts of how your modules or how this is practically applicable to companies, to enterprises. These modules we are presenting here, this course. I think
we were talking about immediate effects that mentioned, or
more or less immediate, yeah. If or when we start sharing these courses or giving these module courses as short courses.
Yeah, well, I think that like one thought I could offer is that I think most companies are worried and should be worried about falling behind on the, everybody's heard about machine learning and what you can and can't do, but that's a question. And but what many don't realize, it's very much more happening than just machine learning. And you don't want young people, because we are becoming so specialized on something, you don't want us to lose kind of the over bird's eye view of how our technologies fit in with the rest of the kind of the sphere. And because I see a lot of examples of people missing and actually falling behind because it's so many things, so many opportunities, so many, technology is progressing slowly because there are too many opportunities. So it's clever to know about more than your own field, I think.
Right. Okay. Yeah. Yeah, I guess Andrei wanted to add something here as well.
I just want to add example of again ChatGPT, which relatively recently came to a public, but I already hear that this is being used by organizations and such problems as people putting internal information to the ChatGPT. So, but big enterprises already now have their own version ChatGPT installed internally, and this is already in use. So, and if I'm not mistaken, like to the public, it came end of last year. So it's time-wise, it's very soon came to the practice. Yeah.
Yeah, I guess, but this is the part that I think Håkon is trying to say, that that's the exciting part that everybody sees. But there's also a lot of other parts, and what our course proposes and shows that are actually practically usable. It's not only ChatGPT and this sort of AI that's going to move the world, but it's all kinds of maybe tinier practical parts that will be used in like you said, the whole value chain and from the molecule to product and back. Right. Thanks for that. I don't know if anybody wants to add anything to this point. I shall move on. If not,
my turn.
No, not exactly. But if you want to add something, yes.
Okay, I have something to add. I think by this course, the owners of some companies can know that the digital transformation is happening in many domains. I think that can make them the owner of companies more confident to invest their resources in the digitalization of their own business process. I think by this they can enhance their current business by improving the efficiency through the knowledge reuse. And additionally, I think they can find some new opportunities to provide new services. For example, to provide some web API for the people who are looking for some specific solution in some specific problems, because the companies are experienced in this kind of problems. I think this is some new opportunity for them. Okay, that is my idea.
Yeah. That's right. Yeah, that's the overarching side as well. Like we found, if I may say so, inspiration from each other's modules. Some companies would just find inspiration from one of the modules there that might not straight away apply to them, but it might come up that they find something useful from other modules as well, other parts of the course. So maybe we go to our team centered again for a second there. What was the biggest challenge throughout generating this course or these modules for you? It's like a opinion question.
Yeah, I'd say maybe the time. Especially we had quite extensive. Of course, we didn't plan to be the chemistry so extensive course, but eventually just kind of happened, because while you develop it, you see, okay, you want to have this type of knowledge, then you have to kind of make it work, and you have to add all the knowledge that is required for the student to eventually be applying that let's say information in the students' everyday work. Other than that, I'd say that we worked pretty nicely together. I think the start was a bit slow maybe, but then as soon as we got to know each other, then it pretty much kicked off. So that's and I'd say, Mikael, you did a nice job to beating us to work. So yeah, and Andrei, of course, was really nice to kind of host us when needed and give a nice gentle push.
Yeah, softer push.
Yeah, exactly. So it's it was never kind of trying too hard to make sure that you have to do this by that time, or that was Mikael's job. So and Other than that, I'd say, yeah, we worked together really well, got to know each other, and maybe it's not my place to say that, but the course looks quite fine.
I can continue by saying, well, it was a very interesting experience for me, and I would highlight that we, as experts in our problem domain, want to stay in our problem domain. So I would like to bring it on. So it's again, idea is, and yeah, in the course, to show this, well, as I put it, tool chain, so like how we can integrate, have this vision, but surely each of us, including myself, let's start with myself, want to kind of, okay, yeah, I'm here with the field. So, and it was interesting that, well, to keep in mind is that surely there is this principle divide and conquer, or separation of concerns, of doing the things. That's also for good reason why we have a specialization and where specialization is useful and necessary. So this course, it was and this project revealed this challenge, and that's also coming back to added value or value of this course, to think when you look at this course, what where is your discipline, where is your maybe comfort zone, and what means to go out of your comfort zone. So it was very interesting for me.
Yeah, that's true. Yeah, that's one of the goals as well for the side of academy and science and such, to get people learning it out of one comfort zone, out of one discipline. So if you take the whole course, you see other windows, other doors, other roads, so you can widen your specter. How about the people online? What was the biggest challenge for you in this project?
Biggest challenge was to catch the 3 o'clock bus from Kotlajärve to Tallinn.
Right, but you didn't catch the bus. I drove you.
Yeah, the second time I think you drove me, but
okay.
the first time we had to be on the bus or not get home.
Yeah.
Oh yeah, I see.
But it's, yeah, sorry, you brought me very nice memories. It's, yeah, like about this journey on the bus. And you say 2 o'clock, just for the audience, it's 2 a.m., right? And it was interesting, yes.
Yeah,
Especially, I maybe, okay, out of record. Yeah, it was just the end of the event. And
yeah. Yeah, it's a late morning, early morning or late night bus ride back. It was in the end of summer course, I guess. Just the background that the summer course and some of the meetings took place in Kohtla-Järve, so people coming from Norway, they got a nice experience as well, I guess.
It was
traveling there and back and such. But yeah, other challenges, or if it was not challenging at all for you, then it's, I mean, goodies for you, cookie points for you. But Liang, how about you? What is the biggest challenge in the project for you?
Okay, regarding the biggest challenge, I think that is to find the common framework, the common story about this digitalization. I mean, in theory, all of us, although we are in different domains, what we are doing is about the digitalization. So I think there should be some common some common plot of our story, and some common problem in our domain that are interested by other people. And I think to find what are they is a big challenge for me, and I hope my part can be helpful for other people. I think that's it.
Yeah, and I think the ICT module is useful.
Backbone.
Yeah, it's overarching and useful for other people, other modules as well. And I think you coined that very well. That one of the challenges we all struggled, I guess, was how to make it all connect, how to make those different disciplines connect into one course, and there was different ways to do it, and we ended up the way it is today. Thanks for that. Björn, how about you? What was the biggest challenge for you in this project?
I think kind of tailoring the material for a particular student, or knowing what the background was. There are very diverse students, so finding the right balance between general knowledge and in-depth. So maybe some of the modules should have been sort of divided into the overview and in-depth, and then people could possibly select to go into more in-depth for a fewer number of sub-modules or something like that. But it would be interesting to see how it would play out in sort of a longer one-semester course rather than the very compressed one-week setting.
Yes. Again, this I think that was the point we struggled with as well. That who is the target group of this course? It's ended up to be introductory course for doctorates and then master's degree students. However, the modules can be taught for enterprises as well to in-depthen the knowledge in this area. However, we couldn't right now implement the really good idea what Björn talked about, that you have like a overarching really introductory, and then you can pick one module you go in depth for the rest of the semester. But that's the future of the course, I guess. Right, but the last thing, how do we see the future of the project and the cooperation around it? I mean, the future is that we want it to be really useful, the course to be really useful for the enterprises, and then for the schools the same. So how we envision that's gonna be done. I think you explained already as part of it. We share the knowledge we get to courses. I think the question would be here: is there any plan to, if there is a possibility to teach these modules?
Yeah, from a chemistry perspective, it's easy because I teach chemistry, so I just add it to my courses. And also, what is the good part is that now we have like experimental part included that's different from the previous stuff we were doing back at college. So that also widens the knowledge base for the students and should be, really beneficial to them and also from my staff and myself, because I have to teach it now. So as usual, if you teach, you'll learn the best. So as cooperation-wise, then maybe we have to talk to Andrei how we can teach chemistry in NTNU. If you know any chemistry and if they're willing to let, or you just can take the course and give them, maybe they're interested. That's something that can be done from a narrow perspective of chemistry. I'd say teaching, let's say, companies in Estonia would be quite hard because there's not too many materials science-based companies, and if they are, they actually already have all the tools because these guys come from the institutions that have taught them everything they need to know about simulation of materials. So, but maybe we can do the cooperation in a way that if I don't have to teach them, maybe they can teach students because it would be their interest to get new workers. Today's students are most likely going to be the future workers of some companies, and if they want to have them, most likely will be kind of cooperating with us. It's
Right.
also in our interest.
Yep.
Yeah, I hope that once we have this online streaming available and the project web page set up, and as was shared today, we have a feedback channel created for accessing the materials. I hope that Walt will learn eventually some parts, and I'm really exciting and hoping to see this course implemented in universities and for practical, for industrial training around the globe. And so again, the intention is not that we teach these courses, we created the content, but we prepared content so we try to prepare it so that it can be taken and taught in different places. So it's with this study guide, what we have here, it's meant for instructing also the future instructors, teachers, lecturers for the course. And yes, we have 9 disciplines. Similar to Alan, I am already integrating to my courses some of the items I got thanks to participation in this project. So same can go with implementation in other places. Some can take just selected modules or even parts of the modules and adapt for their needs. I really excited to see how this will play out.
Yes, and as I already mentioned, those modules are meant to be taught and given out to companies as well. And I hope we in Taltech, at least, I don't know how the system is in Norway exactly, but we will get the possibility to get funding to teach those module by module, or one module or other, whichever has the most interest behind it, to the companies, to the people in the company, so they can actually generate their own solutions in the future. But that's time up with this part. Thank you for the panelists. You can either leave here sitting, because it's just a few words. First of all, I don't know how many people answered the 2 questions with the QR code and the web address here, Online Expo online events page. But we tried to see for a second if we got any summary here. There was no models missing, I see. I already mentioned that was given by feedback. It was cybersecurity, what was mentioned actually, and most useful was voted to be the ICT module, and probably because it was most overarching module, I think, more in general. There's not many answers, there are only 3 answers. But the questionnaire will stay up, I guess, and then we'll try to gather this knowledge as we go by it. So that's not really a good statistics, but oh well, the percentage is good. So yeah, the page will stay up. As we see, there's some interested on the topic. Unfortunately, not so many answers. And then in the bottom here, the questionnaire will stay up as well, so you can answer here as well. Right. The conclusions coming from feedback and from what we learned ourselves and what we received around us. In general, it is found to be a really good introductory course, meaning that it has many different disciplines and modules, so you can either like Andre said, get out of your own discipline, out of your own comfort zone, or if you're an unfamiliar person like me to all of those modules, then you can see a little bit into all of these disciplines, all of these problems and how to solve them, how they are being solved and maybe being solved in the future. There was 3 main things we took out of the feedback that we got from the 19 summer school students, the guinea pigs. We tested the course on, to say so. And the first one was that exactly that I found something in another discipline that actually connects to my research and enhances it. So the same point as we said, that you go out of your comfort zone and find something else that you didn't know about, and you can apply it in your area. There's well-known domains, like everybody knows more or less what robotics is or what robots are, but it gives a bit more in-depth view in the robotics, for example, and helps somebody to adjust their direction with their studies or their work they can use it in. And the third one was for the structure, that some of the people found this new structure and format really inspiring in a way, and they want to go further in developing this kind of structure in their courses and their modules. So in this case, I would say those goals set out by our team were fulfilled, of course, with the international cooperation as well between Norway and Estonia, between NTNU and TalTech. So first of all, international connections and cross-disciplinary connection. We have chemistry and digitalization, automatization, right now sitting on the couch together, two really different areas in some way. and of course, as I said, it roused the interest to actually develop the way that the courses in universities are written and proposed. It roused the interest to actually develop things further in that area. So I guess that's the overarching feedback and the conclusion that we can make, that the project did bring together these kind of points that it intended to. So thank you a lot for coming. Thank you for those three who answered the questions, and those who are online, and of course to those who are watching the recording. And we do sincerely hope that those 9 modules will be actually taught and as practical as they are, and will be useful for the companies in Estonia and in Norway and in other countries, because it's all in English in the future. So thanks, and here we can start having a little bit of a lunch snack, and then a tour at homes. I guess it's lunchtime as well. Thank you, and hear from you.